In this session we shall see the modeling of a concrete gravity dam by using 3D solid brick elements and the static analysis of the model made by 3D solid brick elements for stress and displacements by applying water force. The main screen of ASTRA Pro is open. First we select the menu item file, then select working folder, and as the dialog box comes select folder work on the desktop, click on OK. Next, select menu item file, then structural analysis. This will open the analysis workspace. The current tab is Create Project and input data type is text data. At New Analysis, the project name is shown as Design Job Number 1, click on button Create Project. The project folder is created as Design Job Number 1 inside folder Structural Analysis, which is further inside the working folder Work. The message comes confirming about creating the project folder and click on OK. Next, select the tab Modeling at the top of the workspace, and inside further select the tab 3D Structure Modeling. Under this tab there are some other tabs. The current tab is Joints. Click on button Add at the bottom. The dialog box comes. Type the values for X, Y, and Z for the start joint. And click on the button Add Joint. The joint number and its X, Y, and Z coordinates are listed on the left side panel of the window. In similar way type the X, Y, and Z coordinates of all the joints for the dam structure and every time click on button Add Joint to enter in the list on the left panel. At the end click on button Close to finish the data entry for all 166 joints for the model. Next, select tab 3D Brick Elements and click on button Select 8 nodes. The dialog box comes with the list of all the joints of the structure. Select 8 nodes of a brick element by check marks on joint numbers, first for the 4 joints counterclockwise of the upper face and then for the 4 joints counterclockwise of the lower face. Click on button OK. The brick element with all its 8 nodes will appear in the list on the left panel of the window. Once again click on button Select 8 nodes. The dialog box comes with joint numbers and select 8 nodes for the next brick element. Once the job is completed for all the brick elements, click on button Save Data, and as the dialog box comes, we type a file name as Gravity Dam Data and click on button Save. The data is saved in file gravitydamdata.txt. In multi-session data entry work, user may close the analysis workspace after saving the data, and in next session the data may be opened in by using button Browse under Open Analysis in the first tab page. Create project, continue the work for modeling. Next, we open the tab page Process Analysis and click on button View Pre-Process. This opens the Graphic User Interface GUI for entering various data for the analysis of the model structure. The GUI window opens. Select Tab Properties. We click on button Add, the dialog box comes, we enter various material properties in the boxes. Click on button Add and then close. Next, we open tab Page Supports. We click on button Add, the dialog box comes, we enter various joint numbers in the boxes, select support type. Click on button Add Data and then Finish. The supports will appear in the list on the left panel of the window. Next, we open tab Page Loading. Under Define Load Case we click on button Add, the dialog box comes, the load case number and the load type are entered in the boxes, click on button Add Load Case. Let us consider the HE8 of stored water equals H equals 24 meters in Y direction. Then, the water force equals 0.5 times unit weight of water, which is 1 ton per meter cube, times H equals 0.5 times 1.0 times 24 times 24 equals 288 ton per meter. Nodes for each brick element is at 25 meters in X direction, along the length of the dam. Water force at every 25 meters equals 288 times 25 equals 7,200 ton. This acts in Z direction, on nodes at a height of 1/3 of H equals 0.33 x 24 equals 8.0 meters. Considering high flood situation, let us apply force at the height of 10.0 meters. At upstream face, at height Y equals 10.0 meters, the node numbers are 27, 90, 153, 216, 279, 342, 405, 468 and 531. Next, under Define Load we select Joint Load, we click on button Add, the dialog box comes, the node or joint numbers and the applied joint loads are entered in the boxes. Click on button Add Load. In the similar way we add all joint loads and as it is complete we click on button Close. Next, we select the first tab data file in the GUI window. We click on button Save Data File, the data file is saved and the message comes. We can see the full analysis data on the left panel of the window. After viewing the whole data we close the GUI window. Next, we are once again back to the analysis workspace, we click on button Process Analysis, the data validation dialog box comes, we click on Proceed, as the data validation is done the message comes we click on OK. Next the process dialog box comes, we click on button Proceed to start the analysis for the data we created. As the analysis is over the message comes mentioning about the analysis report, we click on button OK, the analysis report is displayed on the workspace screen. We can see the results and the analysis report can also be opened in Notepad for taking printout. Finally, we close the analysis workspace and this is the end of the current session, on analysis of block type gravity dam with model by 3-dimensional solid brick elements. We hope you enjoyed the video session and we thank you for watching the tutorial video.